Welcome back, friends. Now we will discuss about power penalties. Okay, so what are these power penalties? Okay, next, when there is any impairments effects. So when there are any impairments effects or present in a link, there is a reduction in the signal to noise ratio of the system from the ideal case. Okay, the reduction in SNR is known as the power penalty. It is expressed in decibels. So that is ppx is equal to minus 10 log SNR impairment by SNR ideal. So, what are the chromatic dispersion penalties? So, this chromatic dispersion originates from the fact that each wavelength travels at a slightly different velocity in a fiber, and thus they arrive at different times at the fiber ends. Therefore, the range of arrival times at the fiber end of the spectrum of wavelength will lead to pulse spreading. So, what is polarization mode dispersion penalty? What is polarization mode dispersion penalty? So, here to have a power penalty, less than 1.0 dB, the pulse spreading results from PMD. PMD instance polarization mode dispersion. Next, delta T PMD is greater than 10% of bit period TB, that is delta of T PMD is equal to D of PMD. D of PMD L 1 by 2 is greater than 0.10 TB. Extinction ratio penalty. So, what is extinction ratio penalty? The extinction ratio penalty in a laser is defined as the ratio of the optical power level for a logic 1 to the power level P naught for a logic 0. That is RE is equal to P1 by P naught. Power penalty is given by PPER is equal to minus 10 log RE minus 1 by RE plus 1. So here power penalty for extinction rate ratio can be defined as minus 10 log of RE minus RE plus 1. And it is also defined as the ratio of P1 by P naught. Okay. Next, error control. If in any digital transmission system the errors are likely to occur even when there is a sufficient SNR to provide a low bit error rate. Okay, these errors are likely to occur even when there is a sufficient SNR to provide a low bit error rate. Okay, so if there is a sufficient SNR, there should be the low bit error rate. Okay. To control these errors, first it is necessary to be able to detect the errors and then either to correct them or retransmit the information. Okay, or retransmit the information. Error control. Two basic schemes are used for error correction. That is automatic repeat request, and the second one is forward error correction. So, what are those two? Automatic repeat request and the forward error correction. So, what are the error techniques? How they control the errors? The ARQ technique uses a feedback channel between the receiver and the transmitter to request message, and retransmission in case errors are detected at the receiver. Each such retransmission adds at least one round trip time of latency. Okay, one round trip of latency. Each such retransmission adds at least one round trip time of latency. So, what is the ARQ error correction? How this error correction may be occurred in ARQ? Simply, the transmitter controller is connected to encoder, and this encoder is connected to decoder, and this decoder is connected to receive controller, and this receive controller is again connected to the transmit controller by the feedback channel. Okay, by the feedback channel. Basic setup for an ARQEC scheme. So this is what the error correction scheme. So forward error correction. So how this forward error correction may occur? So in FEC, the redundant information is transmitted along with the original information. Here it is transmitting along with the original information. If some of original data is lost or received in errors, so if some of original data is lost or received in errors, the redundant information is used to reconstruct it. Okay, the redundant information is used to reconstruct it. So FEC avoids the shortcomings of ARQ. Okay, it will avoids the shortcomings of ARQ. And next, error detection. So what are the error detection techniques here used? Okay, what are the error detection techniques here we use? That are parity check codes, Hamming codes, polynomial codes, cyclic redundancy check. Next, analog links. So, what are the analog links here we used? So, electrical analog input signal. This input signal is given to optical transmitter. This optical transmitter is given to optical fiber channel. This optical fiber channel is given to optical amplifier, and this optical amplifier is connected to the optical detector, and this is connected to the CNR. So here CNR, electrical analog output signal to RF receiver. Okay, here the analog output signal to RF receiver. This is what the analog links here we observe. So mainly optical transmitter involves harmonic distortion, intermodulation, RIN and laser clipping, and the optical fiber channel, it will modifies the attenuation, GVD and modal distortion. So optical amplifier, ASE noise. Okay, ASE noise. Optical detector, it will detects the short noise, thermal noise, amplifier noise and APD gain noise, and that is given to the CNR. These electrical analog output signal to RF receiver.